platform. I'm thankful to you, ma'am, for accepting our invitation out of your busy schedule. I extend special thanks to our respected Chairman, College Governing Body, Dr. Meena Pimplapure, for sending her best wishes and blessings. It's my privilege to introduce you our invited speaker, Dr. Anita Dutt Konarlal. Dr. Anita Dutt Konar completed her PhD in chemistry from University of Calcutta in the year 2008 under the supervision of Professor Animesh Pramanik. Subsequently, she moved to University of Bielefeld, Germany for her postdoctoral studies, where she spent a period of 2 years till 2010 working with Professor Norbert Sewold. After that, she returned to India and joined IISER Bhopal as DST Young Scientist, where she worked for 3 years till 2013. In 2014, she joined Rajiv Gandhi Technological University Bhopal as UGC Assistant Professor, recruited through the flagship of UGC Faculty Recharge Program of UGC and is serving the university till date. She has visited several countries like Japan, Singapore, Germany, etc. for research and academic perspectives. She has published more than 40 research papers and book chapters in international journal of high repute. 4 students have completed PhD under her supervision and 3 more are pursuing till date. Her research interests focus on the design and development of peptide-based material for versatile applications. She has vast experience in different fields of academics and research and received many awards. Without further delay, let's welcome her for her presentation. Dr. Anita Dutt, madam.
Ma'am, am I audible?
Yes, you are audible.
Okay. So first of all, good afternoon to all of you. First of all, I'm very much thankful to Nina ma'am and the Department of Chemistry for inviting me for this presentation. So Nina ma'am has told a lot about me. So without further delaying, just let's start with the topic for today. So can it be seen, ma'am?
Yes, ma'am. Ma'am, it's visible.
Okay. So as you can see, so students, ma'am told me most of the audience will be students with faculty members. So a warm welcome to all of you. So first of all, as you can see that the title of my presentation is Designer Bio-Inspired Hydrogels, a key to biomedical challenges. So don't get worried by seeing so big names. In a very simple form, I will try to explain that what we do in our lab, along with some of the very basic things, very basic concepts, which we study in chemistry, and that we try to explore in a different way. So let's start with this. Can you see, students, what are these? These some of the gels which we use in our day-to-day life, like these are some of the gels which we use in our day-to-day life, like the hair gel, the body gel, some of the gels which are used as medicine, so on and so forth. So the question that may come in your mind first, that what are these gels? Gels are nothing but an important class of soft materials derived from high molecular weight polymers. They might be natural or synthetic. Now, based on the solvent content in them, which is commonly classified or defined as vehicles, they are categorized into 2 categories. That means if the solvent present in them is water or any physiological buffer, those category of gels are known as hydrogels. And if the solvent is any organic one, like methanol or ether or any hydrocarbons, those classes of gels are known as organogels. So what did we learn from here? That based on the vehicle system or the solvent present in the gel, gels are being categorized. Then their affinity to absorb these solvents is mainly focused on the presence of hydrophilic groups on them, like hydroxy, sulfonic, carboxylate, etc. Then you may ask me that how are these gels stabilized? Gels can be stabilized by a number of interactions. First of all, they might be stabilized using strong covalent interactions, which are being represented by solid lines. They might be stabilized by weak non-covalent interactions, which are being shown by dotted lines. Or they might be stabilized by a combination of covalent as well as non-covalent interactions, as has been shown here. But for the entire talk, I will be focusing on scaffolds which are being stabilized by non-covalent interactions. Then in the terminology of my title, I have utilized one word, bio-inspired hydrogels. So you may ask me that what do we mean by bio-inspired hydrogels? So for this, I would like to say you that hydrogels which are derived from peptides are mainly known as bio-inspired hydrogels, which I will be dealing with in my entire presentation. So the next question that obviously arises is, what are peptides? Now, peptides, every one of us, we have learned in our 10 plus 12 or BSc something. We all know about peptides, but in case we have forgotten about it, a quick recapitulation of whatever we have studied. That peptide molecules are nothing but polymers of amino acids which are linked together by the formation of an amide bond between the carboxylate of one amino acid residue and the amine group of another amino acid residue to form a bond of this type. Now, we can see that this amide bond possesses a double bond character around this amide, which restricts the rotation around this axis. As a result, this restricted rotation around this axis confers the peptide molecules with wonderful properties. Now, mainly when I teach in the class, many students are confused with one of the topic that, ma'am, what is peptide and what is protein? So for them, the clear answer is that if in a molecule you have more than 50 amide bonds, then such type of scaffold is known as proteins, and if it is less than 50, you call it as a peptide bond. So students, please keep this in mind. Then, as I told you that in my entire talk, I will be discussing on molecules with non-covalent interactions, that is peptides. So the next question that obviously arises is that what are the factors that stabilizes peptides? So peptide molecules are stabilized by hydrogen bonding, pi-pi stacking, hydrophobic interactions, electrostatic interactions. Now I have taken one figure from the internet. Can you see? Is it visible, students? That a figure on the right hand side. This figure is a figure taken from Gulliver Travels Swift by Jonathan Swift. I would like to convey, it is that the collective power of weak interaction is much more powerful than a single strong interaction.
Yes, ma'am, visible.
Ma'am, are you telling me something?
No, ma'am, no, ma'am.
Okay, so by this, if you see the figure, that the collective effort of these small Lilliputians were very much strong enough to win over this giant Gulliver. So you can think how peptide molecules, how the non-covalent interactions can make wonders. Now, what is the basic recipe for hydrogel formation? Now, a student may always ask me that, ma'am, if in a particular molecule, we have groups which can form good hydrogen bonding, pi-pi stacking, hydrophobic associations, electrostatic associations, will all these molecules form gel? So for that particular student, my answer will be no. The correct recipe for hydrogel formation is that there should be balance of non-covalent interactions. Balance, where there is a balance of non-covalent interactions, you will get a hydrogel or any type of gel. Places where this balance of interaction fails to be maintained, there no gel formation occurs. Then, what is the basic principle of hydrogel formation? Now, we have learned that we all know that amino acids, when they are form a peptide bond, they adopt a definite primary structure. That means the amino acids are just linked together. If you just note the balls, then what happens under the influence of a particular stimuli or any favorable conditions, these primary structures adopt a secondary structure, and with the help of non-covalent interactions, these secondary structures adopt a tertiary structure, which ultimately forms a nanofibers. Now, on increase of concentration, elongation of the gel fibers occur, and finally, on further time, you will notice that a network is being formed, just similar to that of a filter used for filtering tea, which we use in our day-to-day life. That if solvent molecules get entrapped within this network, the solvent molecules are represented by green balls, a gel formation occurs, and the formation of the gel is being confirmed by inverted vial method. That is, you just invert your test tube, you will find that the mass already stuck to the bottom of the test tube. It will not flow out. Then the question comes, why did we choose these peptides? This is because peptide molecules are composed of eco-friendly amino acids, which are biocompatible in nature, biodegradable in nature. The synthesis protocol is very, very simple. And the most important point is that they are formed through self-assembly, utilizing non-covalent interactions, unlike other polymers that requires drastic conditions or complex techniques for its fabrication. Then any of the student might be interested to know that how do we synthesize peptide-based hydrogels in the lab. So for that particular student, please students focus on, these are very simple things, very simple concepts that we are trying to explore in our laboratory. So for this, we take requisite amount of sample, which we plan to explore as a gel. Then add solvent to it dropwise and maintain the volume till 1 ml. Then applying external stimuli, we homogenize the solution. And if the molecule possesses the tendency to form gel, then after stipulated period of time, which may vary from minutes to hours to days, your gel will be formed. And how will you confirm that whether your gel is formed or not? By inverting the test tube, and you will find that if your gel is formed, it will not fall. It will not fall from the test tube when you invert it. Then here I have used another terminology, external stimuli. See students here. So the next slide will tell you what are the external stimuli that might be used, or what are stimuli responsive gels. Now in modern research, one of the very important terminology or scaffolds that are being used for versatile application is stimuli responsive hydrogels. So what are these stimuli responsive hydrogels? There are a class of gel molecules which undergo a gel to salt transition. That means here it is no more a gel on the application of a stimuli, and then again back to the gel phase on removal of the stimuli. So such molecules which exhibits a gel to salt transition on the application of stimuli and back again to the gel phase on removal of the stimuli are classified as stimuli responsive hydrogels. So what can these be stimuli be? These stimuli might be mechanical stress, electrical energy, thermal, magnetic, some chemicals, light, redox potential, some enzymes, etc., etc. So you might be interested to know that what is happening over here. What is happening? So the most important concept, if you just focus on the figure over here, that here gel, in the gel state, the molecules are present in an organized fashion. They are in an organized orientation, but as soon as you apply a stimuli, it enters into the random orientation. That means it changes into a salt phase. Then if once you remove the stimuli, it again gets back to the gel phase. That means again random to ordered orientation occurs. Then in research, nothing works out until and unless you describe the applications of your material or gels, what you want to say here. So here, literature documentation reveals that peptide-based hydrogel materials possesses a wide variety of applications like bioimaging, cancer therapy, tissue engineering, antimicrobials, etc., etc., and so more. But I am just focusing on these few things. But what is the actual criteria that is determining the application avenue of your gels? So it is nothing but the gel strength, that is the fiber strength. Fiber strength. This is the actual parameter that determines the gelation application avenue. So if you just focus on this figure, which is described over here, this is a case of stable gel. By this, what do we need to convey? Here you can see that two persons are pulling this material from both the sides, but the gel is remaining intact. It is not disintegrating. So it is a case of stable gel. But here, in this case, you find that both the persons, the same persons are pulling from both the sides. It is just a cartoon representation in order to show the stability of your material. But in this case, we find that disintegration is occurring. That means it is a case of unstable gel, or the material is not able to form a stable gel. Then I told you about the gel strength. Now the question comes that how will you determine this gelation property of the molecules? So gelation strength of the molecules. So gelation strength is measured by a science known as rheology. I will try to explain in a very simple way. The word rheo means to flow. Logos means science, and ology means the study of. So rheology is a science that is concerned with the flow of liquid and the formation of solid. Now, in this rheology, in gel phase, we will be encountering on many different parameters. But please, students, don't get confused with it. Just focus on these four parameters like stress, strain, G dashed and G double dashed. I will explain to you each and everything. Now, what is this stress? Stress means the force per unit area. And that is the load. That is the load. And strain means the strain or the means force that your gel fibers can bear. Okay, that is the strength your gel fibers can bear. Please don't get confused with these terminologies. These are two terms, and another two very important terms which we will often use in our presentation, that is G dashed and G double dash. That is viscoelastic modulus. G dashed, which is known as the storage modulus, and G double dashed, which is known as the loss modulus. Now, somebody from here might ask me that, ma'am, how will I know that what is the important criteria for a molecule to be classified as solid, liquid, and gel? So if you find both the G dashed and G double dash to be identical, you get a solid phase. If your G dashed is much higher than G double dash, that is your storage modulus is higher than your loss modulus, you get a gel phase. And if your G double dash, that is loss modulus, is much higher than your storage modulus, you get a liquid phase. So students, please keep this one in mind, that for a gel, we find your G dash, that is your storage modulus, to be higher than that of G double dashed. Then you might be interested to know that how do the graphs or how do your experimental data looks like when you perform a rheological experiment. Now, to determine the strength of the gel, the two experiments which are common done is a frequency sweep experiment and an amplitude sweep experiment. That means in frequency sweep experiment, where we plot or we probe the modulus as a function of angular frequency, and in the amplitude sweep experiment, we probe the modulus as a function of strain percentage. Now, this I have just tried to show that what are the basic techniques do we use for determining the strength of the gels. Now you might be interested to know that what do we do in our labs. So currently our group is focusing on a variety of applications like drug delivery carrier, antibacterial activities, effluent management, industrial wastewater treatment, varieties. But as I have mentioned in my talk, that I will be focusing on biomedical challenges. So here I will be mainly discussing the works that we have contributed as a drug delivery carrier, antimicrobial activities, anti-inflammatory activities, wound healing activities, etc. So if somebody is working or is interested to work in this direction, you might be interested to know that what are the parameters that should be kept in mind while you are designing molecules for drug delivery applications. So for designing any molecule for drug delivery or biomedical applications, rather to tell you, we should keep in mind that our molecules should be biocompatible, injectable, and proteolytically stable. So don't get worried about these terminologies. I will explain each and every concept in my upcoming slides. So coming to the first part, injectability of the hydrogels. So by now we have already, I think, I don't know how much I am able, but I have tried my level best to explain the concept of injectability. That is not injectability, stimuli responsive hydrogels. That is your gel, our gel, when it is in the gel state, the molecules present are organized in a fashion of this type. But the sooner we are applying any kind of stimuli, the organized fashion orientation gets disrupted and we end up with a disordered orientation. So such type of demonstration we need to prove with the help of some experimental techniques, which has been shown here. If you just focus on this figure, that we already learned that for a gel phase, your G dash, that is your storage modulus, should be higher than G double dash. So you can see that your black line is much higher than your blue line. So this is a gel phase. Now, at once you are applying stimuli to it, it underwent a transition to the sol phase. Sol phase means this is a liquid phase. And in such case, we already learned that the G double dash, that means your blue line went above the black line, that is your storage modulus. So this indicates the sol phase. So, but this result needs to be repeated a number of times to check that whether the experimental observation that you are getting is not an accidental one. The reaction or whatever experiment or whatever properties you are trying to claim, it should be reproducible, that you should check again and again. So in this way, we check the injectability of the hydrogels. Then comes another important terminology which I mentioned is the biocompatibility of the hydrogels. So biocompatibility, generally by this experiment, we get an information that whether your material or hydrogel is showing non-toxic behavior or not, since we are focusing on biomedical applications. So for this, what are the two different techniques used? They are MTT assay and hemolytic assay. There are many other techniques, but currently we use these techniques in our lab. Now, I would just like to tell you some brief informations about these techniques. Now, MTT assay. So, MTT assay is nothing but a colorimetric assay. Colorimetric assay where we find a color change. Now, the thing is that MTT is basically a dye with a huge name. But if you just focus on the structure of this, it is containing a tetrazolium ion, tetrazolium ring. Now, the basic idea is that means in living cells, where you have your proper cell division occurs, or normal all cell metabolisms occur in a means normal way, there your mitochondria, which is the powerhouse of the cell, it generates an enzyme which is the NADPH oxidoreductase. So the basic concept is that if you incubate your cells with this type of dye, MTT, then if your cells are alive, that means that particular enzyme, NADPH oxidoreductase, will be secreted. As a result, the tetrazolium will be converted to this brilliant violet formazan dye. And the intensity of this dye will give you a measure of the cell viability, that whether your molecule is biocompatible or not. Another assay that we commonly do is a hemolytic assay, where your normal blood is being treated with different concentrations of the hydrogelators that we design, and its percentage hemolysis is noted or observed, and the higher is the percentage of hemolysis, that means your molecule is less hemocompatible. Then another terminology that needs to be kept in mind while designing materials for biomedical applications, they are the proteolytic measurements or proteolytic studies. So by this, don't get confused, just try to understand in a very simple way. See, this is nothing but a peptide chain, which we have tried to represent in this manner as balls. Now, there are some enzymes which are present in the body which are able to recognize these peptide bonds. As a result, it undergoes cleavage and it breaks the peptide molecule or protein molecules present as such. So now, what do we mean by proteolytic stable vehicle? That means, suppose you want to devise a vehicle. These red balls are nothing but drugs. We just tried to explain in the form of a cartoon diagram. Now, for a proteolytic stable vehicle, we need to show, or we feel that our vehicle should perform its action and then leave the system in an unperturbed manner, that is without creating any more problem within the system. But for a proteolytically unstable vehicle, so in addition to performing its function, what happens is that sometimes there occurs breakdown of the entire vehicle. So that is not at all expected. because at times they may create some problems in the biomedical application. So this should be kept in mind while you are designing the scaffolds. So the first application that I will be discussing over here is drug delivery carrier design, where we have contributed significantly. So as a drug delivery carrier, we already developed hydrogel nanoparticles as a drug delivery carrier. If you just focus on here, you find that this is a nanoparticle, entire one. These red balls are the dyes. So what we wanted to do, just a simple diagram which I explained over here, that a vehicle which is containing the drug molecule, and then after your work is done, after your delivery, the vehicle should leave the system in an unperturbed manner. So this can also be represented in the form of a Trojan horse, which we have shown over here. Now, the first work that I am presenting over here is drug delivery carrier design. Here, we have designed a mechanoresponsive, proteolytically stable, biocompatible supergelators from ultra-short enantiomeric peptides with sustained drug release propensity. Now, this work is being done by my student Radha. She is my third PhD student and she already submitted her PhD thesis. Now, don't get confused by looking at a complex title. Just try to focus what I am trying to say. Now, based on the parameters that promotes gelation, we have designed a set of hydrogelators containing two different fragments. First of all, where n equals to 8, that is a component or an amphiphile where n equals to 8, and tethered to different amino acids of diversified configuration, where for hydrogelator 1, it is a case of L-phenylalanine, and for hydrogelator 2, it is a case of D-phenylalanine. So our experiments reveal that when n equals to 8, irrespective of the nature of the configuration of the amino acids, we get or we observe gel formation to occur. But the sooner this n equals to 8 is changed to n equals to 10, then the molecule fails to show any gelation property. So I think you remember that I mentioned that even if you have large number of groups in your molecule with variety of donors or variety of non-covalent interactions, you may not get a gel until and unless you are able to maintain a balance of covalent interactions. So these molecules were synthesized using conventional solution phase methodology using racemization free techniques, and if somebody is interested can go through our reference. Now, this is a case of mechano-responsive gels, which I already mentioned. That is a stimuli-responsive gel where your stimuli is mechanical stress. So what I told my student Radha, that first of all, in order to check that whether your molecule is stimuli-responsive or not, you shake. First of all, you shake your molecule. And then she did, when it got when it underwent a gel to salt transition, as has been shown here. Under such cases, it would be withdrawn in a syringe, and then when again it is given back and then left undisturbed for some time, it formed gel. But as I mentioned, that visual demonstration do not work only, and for science, you always need to provide some experimental evidence, which we did. And Radha, for this, the angular frequency sweep and step strain measurements were performed. And for Radha, she observed that both the molecules showed gelation properties. That is, your G dash is much higher than G double dash. That is, your storage modulus is much higher than your loss modulus. Then the step strain measurement, which I told that in my earlier example, it proved the injectability of the hydrogels. Now, here again, as I mentioned, for designing any material for biomedical applications, the proteolytic study also needs to be kept in mind. So Radha also found that both her molecules were proteolytically stable till 48 hours. And how did she do that? She performed, or she incubated her samples with the proteolytic enzyme proteinase K and performed mass degradation assay. And then she found that till 48 hours, the molecule was completely stable. Then the biocompatibility was proved using 4 different cell lines of diversified nature when maximum cell viability was found. Then Radha prepared hydrogel nanoparticles using the standard inverse emulsion technique. If somebody is interested, can go through our reference. I will not go very details to it. Just I would like to mention that using the standard inverse emulsion technique, where your aqueous phase and organic phase is taken, which here we had taken light paraffin oil, and inside it we have added the hydrogelator molecules dropwise, hydrogelators containing drugs. And if you just look here, that here the organic phase, which also contained the surfactant molecule, got attached at the surface of the nanoparticle. This is a nanoparticle, but after your experiment, how will you know that whether your particle has gone to the nano range or micro range? So we, in order to confirm that, we have used a Gita sizer and confirmed the size of the particles, and we found that our molecules, or the particles which were prepared, were within the nano range. Just focus here that these are the structures of the hydrogelators that Radha had designed. These are the 2 drugs. One is a very small drug, 5-fluorouracil, and another one is a bulkier drug, which is the anti-cancer one, doxorubicin. And this is the surfactant that have been used. Why am I telling you? You will just come to know in my upcoming slides. In the next slide, then we were interested to check that the release kinetics, because we were interested to devise a drug delivery carrier. So we were interested to check the drug release kinetics from your hydrogel nanoparticles. So we have performed the release kinetics with both the drugs, 5-fluorouracil and doxorubicin. Interestingly, it has been found that for the smaller drug, 5-fluorouracil with a molecular weight of 130, both the hydrogelators 1 and 2 till 45 hours showed a release percentage of around 45%. But as soon as we shifted to the bulkier drug, that is the doxorubicin, there we observed that till after 80 hours, 50% of the drug was released. After that, a saturation limit was reached. Now, in order to explain why this difference in this release kinetics have occurred, we have performed computational studies with the help of our collaborator, Dr. Anindya Basu. He is one of the colleague of mine in the SOPS pharmacy department. Now, interestingly, we observed that if both the molecules, if 2 molecules were arranged in the form of a clip, and the green one is your small drug, 5-fluorouracil, and you can see that this drug is associated at the gate, at the mouth of a cliff, in order to maximize non-covalent interactions. So since it is present at the mouth of the cliff, then its release from the hydrogel matrix occurs at a much faster rate. Because we know that if in a house somebody is just waiting at the gate or at the doorstep, then he or she can go out much faster than somebody else who is sitting inside a room. So the same case is with doxorubicin. Here we find that this larger, bulkier drug is sitting in the middle of the clip in order to maximize non-covalent interactions. As a result, its release from the hydrogel matrix is occurring at a much slower rate. So this work of Radha's is being published in the year 2020 in New Journal of Chemistry, published by Royal Society. So as I mentioned, we have contributed significantly in the area of drug delivery applications. So this is another work by Radha. This was published in 2019 in the same New Journal of Chemistry by Royal Society. So these are two other works explored by my second student, Priyanka. She has already been awarded PhD this year. And she has published in Chemistry Select by Wiley Intersciences in the year 2019, another one in New Journal of Chemistry in the year 2018. Some more works in the area of drug delivery has also been reported by Priyanka, this in the Chemistry Select in the year 2017, and this is also in New Journal of Chemistry 2017. Now, this is another work, another different area. Apart from drug delivery, I mentioned that we work on different other areas, that is antimicrobial properties. Now, the thing is that you might be interested to know that why did we explore this? Now, microbial infections accompanied by inflammatory responses are one of the major challenges encountered by medical practitioners to date. The presence of pathogenic microbes at susceptible interfaces or wounds at times enhances the level of toxins in the body, which delays the wound healing process. So although a significant number of antimicrobial agents are reported, but it suffers from several drawbacks because none of the reported molecules could address both the complications of antimicrobial problems, antimicrobial challenges, as well as inflammatory challenges together. So in an effort to design these molecules, design significant or a solution to these type of problems, my student Noreen, she designed a set of molecules and which I will be presenting over here, and she was assisted by two of my other students, Mr. Vaibhav and Rishabh. They are currently extensively exploring these properties in my lab. So what Noreen reported is that a heterochiral diphenylalanine, everybody knows homochiral, heterochiral, auxine derivative empowers remarkable mechanical integrity with promising anti-inflammatory and antimicrobial performances. Don't get confused with that. I will try to explain in a very simple form. Now, as I already mentioned, based on the parameters that stabilizes or promotes deletion properties, Noreen designed two molecules, hydrogelator 1 and hydrogelator 2, where the chirality of the molecules, that chirality of the peptide units were kept constant. That is, it is the L and D isomer, and she has coupled this to 1-naphthyl acetic acid as hydrogelator 1 and 2-naphthyl acetic acid, where she got designed hydrogelator 2. And interestingly, she observed that irrespective of the nature of naphthyl acetic acid, both her molecules showed extensive gelation propensity with mechanoresponsiveness, and the mechanoresponsiveness was also confirmed using rheological measurements. She could also prove her molecules to be proteolytically stable, and she found that till 48 hours, both the molecules hydrogelator 1 and 2 showed proteolytic stability. Her molecules were also biocompatible, as she confirmed this from MTT assay using cell lines HEK293. Now, interestingly, she used both of her molecules for antibacterial studies. So for this case, she has used positive bacterial stains, S. aureus and S. mutans, and she found that both the hydrogelators showed good antibacterial behavior with the positive stains. But unfortunately, she also tried the experiment with the negative organisms, E. coli and Klebsiella, but she found that both her molecules were found to be resistant. Her molecule were also found to show antifungal activities using the two organisms, Candida albicans and A. niger. She also tried to explore the anti-inflammatory activities, where she tried to determine the percentage inhibition using the receptors MMP2 and MMP9. So what are these? These are nothing but inflammatory markers. And she found that both of her molecules showed good anti-inflammatory behavior. But exceptionally, hydrogelator 1 showed almost 85% behavior, anti-inflammatory behavior with respect to the positive control, which she has used as tetracycline hydrochloride. Now, in order to get more details about this anti-inflammatory activities, she performed concentration dependent experiments, and she found that in this concentration, 31.25 microgram per ml, her molecule showed maximum anti-inflammatory activities of around 95 and 92% in both the receptors MMP2 and MMP9. Thus, this work of ours is being recently published in the journal, New Journal of Chemistry, published by Royal Society just in the month of August. Now, another work in this direction, this is very, very interesting, but I would not go in much details into it, where this is being reported by my student Priyanka. This is also a similar kind of work where chiral orchestration, that is, if you just focus on this figure, here there are A and B, that is the chirality. Priyanka tried to play around this chirality, and she developed a set of molecules from where she could fish out an important molecule with antibacterial as well as anti-inflammatory properties. But I will not go any details about it. So her molecules were also found to be very much stable and also showed mechanoresponsive behavior, as has been demonstrated by the mechanoresponsive step strain rheological measurements. She also conducted her experiments using 4 different bacterial strains, that is E. coli and Klebsiella, which are the negative ones, and S. aureus and S. mutans, these are positive ones, and her molecules were found to be show antibacterial nature. But that is not our main. Her molecules were also biocompatible. This is the most important part that I would like to focus on Priyanka's work, that here her molecule 1, which contained LL, that is where both the configurations, this one, where both the configurations of the chiral centers were LL, showed 90% inhibitory activities. Now, for any particular experiment or any particular drug or biomedical application, your work gets more recognized if you can give some information about in vivo applications. So in order to get an idea about it, we try to check that whether our molecule shows anti-inflammatory activities in animal model also. So we have carried or used the rat pouch model of acute inflammation. This experiment was done in collaboration with Dr. Ankit Mishra of VNS College. Now, what did we do here? Students, please try to listen to this. This is one very important concept that is being used. For this assay, 5 different groups of animals were chosen. One group, group 1, where normal mice, that means where no inflammation was there, that was chosen. For the second category, what was done? Some inflammation, that is rat pouch, that means pouch was induced by using an injection, that is carrageenan. In the third group, the same diseased mice was treated with the standard drug. In the fourth category, the diseased mice treated with low dose of a hydrogelator. And in the fifth category, diseased mice treated with a high dose of the hydrogelator. Now, after following standard protocols and ethical guidelines, the animals were sacrificed. That means they were after sacrificing them, then we have performed or we analyzed the animals in different ways. First of all, that is the histopathological measurement, where the tissues of various groups of animals were compared, and another one, samples from blood and ear pouch would be examined for total and differential WBC counts and lipid peroxidation assay. This is some of the parameters that are looked into. Now, this figure I would just like to share with you and just show that this is a normal mice, and this is one mice where the inflammation is being induced using carrageenan. Now, after comparison with the 5 different tissues of 5 different groups of animals, it has been found that for the normal one, the interstitial spaces are minimum. This is the normal one. Here, this is a diseased one, that is a one where inflammation was there. There we find that here are a lot number of dots. This is the interstitial spaces are being present in a huge number. That is the animal is having inflammations. Then this is the third category where the injured mice is being treated with a standard marketed drug. And here we find that the dots number, that is the interstitial spaces, have reduced. In the fourth and fifth category, the diseased mice treated with a low dose of our hydrogelator, and this one in a higher dose of our hydrogelator. And we found that in the case of higher concentration of our hydrogelator, it is almost resembling that of the normal one, that our hydrogelator. So what conclusion are we coming up to? That our hydrogelators showed good anti-inflammatory activity in vivo also. Another experiment which I mentioned, that here another parameters that have been probed is the WBC count from the whole blood as well as the air pouch exuded of the sample. And we found that for hydrogelator, the amount of WBC count is much lower or is comparable to that of the positive control. From the whole blood also we get the same information. Then coming to the lipid peroxidation assay experiment here. So here what do we get, or what informations are we getting from here? Lipid peroxidation assay is nothing but an assay where MDA, that means malonaldehyde, is being produced as a byproduct. Now, the concept or the idea is that higher is the concentration of this MDA produced, less biocompatible is your molecule. But we find that here for our hydrogelators, in comparison to the positive control, much lower concentration of this MDA is being produced. So it again further emphasizes the anti-inflammatory potential of our molecules. So this work of Priyanka is being published in the year 2021 in one of the very prestigious journal, ACS Applied Biomaterials. Now, I think you are already tired of, but I won't take much of your time, but I would just like to give you one very important example using a very simple concept, what we study in our graduations or master degree. That is effluent management. Now, what is this? By this, what do we mean to say? That we all know that hydrogen halides are a class of non-toxic entities which are released into the atmosphere, and its exposure to the atmosphere causes detrimental effect to health. Detrimental effect to health not only to humans but also causes leaves a huge impact on the aquatic balance. So designing of molecules which can remove selectively these hydrogen halides from the atmosphere are of huge importance. So keeping this view in mind, my first PhD student Ankita, she designed a set of molecules, again using an amphiphile, where X is there. I will tell you what is this X, and then she combined with different varieties of XA. XA are nothing but different heterocycles. Now, she found that when X is OH and XA is tetrazole, in the presence of HCl and HBr, she found gel to occur, gel formation took place. Then again, for compound 2, when X is OH and XA is aniline tetrazole, she again found gel formation to occur. But in case of compound 3, where instead of OH, she replaced this OH with H, that means and this XA remaining fixed, and she used HCl and HBr, but she could not find any gel formation to occur. Then what I told her is that you please explore, you try to explore these molecules with variety of different other mineral acids like phosphoric acid, boric acid, perchloric acid, trifluoroacetic acid, normal acetic acid, sulfuric acid, nitric acid. She repeated all the experiments with this gelator, but she did not find any gel formation to occur. Then we were interested to see, here we have performed the experiment where HCl and HBr was in the liquid form. But you know that these effluents are released in the gaseous form. So we were interested to check whether this gelation could occur in the gaseous form also. So Ankita generated HCl vapors and performed the experiment with both the molecules HCl and HBr vapors, and she found that this experiment works equally effectively with the hydrohalic acids, both in the gaseous phase also. Then we were interested to find out that what is the actual concept? What is the actual concept behind this self-assembly? Then for this, a lot number of computation calculations were done, which I will not be telling you. But the basic concept that I would like to focus on is that it is simply a nucleophilic substitution reaction where OH was, when it was treated with HX, a nucleophilic substitution reaction occurred and OH got replaced with this X. And we found gelation because, and when this OH was not there, only H was present, there no nucleophilic substitution could occur. So that is the reason the molecules failed to form gelation properties. So this is nothing but a pictorial diagram just to show our concept that here the basic concept is that X minus or halides are being released into the atmosphere. So what did we propose? Our proposition was that if we contain a methanolic solution of our molecule, which is being shown here, and then if it is treated of, if it is brought in contact with HX gas or liquid, whatever might be, a simple nucleophilic reaction, nucleophilic substitution reaction occurs where OH gets replaced by X, and then it is actually this substituted forms X form which self-assembles and forms this network where encapsulation of solvents occur to form gels. So as I already mentioned, your claim would not be accepted in the scientific community until and unless you are given, you provide experimental evidence in support of your claims. So for this, we performed a simple NMR experiment with the solid sample as synthesized, and that also in the zero gel phase. Zero gel means in the gel phase where nucleophilic substitution already occurred for both the hydrogelators 1 and 2, and we observed that for the solid compound OH could be observed, but when we performed NMR with the zero gels, that means with dried gels, we could not find any OH peak to be present. That means definitely our molecule have gone or underwent nucleophilic substitution reaction. That is the reason no peaks could be seen. So this experiment was also confirmed using mass spectrometry, where we observed peaks corresponding to the halide derivative. And finally, another thing that Ankita tried to explore is that when X equals, this is the design molecule, which I already explained, that here XA, X is OH, compound 1, XA is this tetrazole. She observed gel to occur. X is OH, XA is this one, gel to occur. But here, if you just note that the aromatic rings are present in the backbone, but when she moved to compound 3 and 4, where she shifted the aromatic bulk to the side chain, this is the backbone. Backbone means this one, the skeleton, and side chain means this is the side parts. So when she shifted this one, the bulk, she also found gelation to occur. So this is, then she concluded that this now might not be the main driving force. So what is the driving force? Then in order to confirm that, she again replaced this X with H, and she found no gelation to occur. So this work emphasizes the importance of hydroxy group present in the amphiphile in driving the gelation mechanism. And she is my first PhD student. She is currently working in Excellence College. She has published 2 of her research. She had many papers, but out of these 2 are the research papers which I have presented here. New Journal of Chemistry in 2020, followed back to back another New Journal of Chemistry 2020. Now finally coming to the acknowledgement part, without acknowledging my collaborators, Professor Amit Tiwari from University of Toledo, my colleague in RGPV Bhopal, Dr. Anindya Basu, and of course my husband, Professor Sanjeet Kunar of IISER Bhopal. And then to the funding agencies, SERB, UGC, MPCST, TechWhip. And I would have never been here without my students. So this is my research group. This is my research group. My first PhD student, Dr. Ankita. My second PhD student, Dr. Priyanka. Dr. Radha is not yet doctor. She has already submitted. Arvind also submitted her PhD thesis, and Noreen will be presenting soon. And Rishabh and Vaibhav, they are working very hard in order to get their doctoral degree. So this is all about what I wanted to say. And students, if any of you are interested to pursue your research projects or PhD, you can contact me. My mail ID and phone number is here already. It is there with your other ma'ams, and of course Nina ma'am. And thank you all for your kind patience.
Thank you, ma'am. Thank you so much for your informative talk. I'm sure our student must have, your talk must have intrigued our students to know more about hydrogels. Thank you once again, ma'am. May I now request our principal, Dr. Asha Agarwal, ma'am, to say a few words of motivation. Ma'am, in the meantime, you can also ask questions.
Yes. The forum is open for question, please. Actually, I am unable to stop this one. Can I, first of all, let me stop sharing my slide.
Yes, of course, madam.
Yeah. Namaskar, ma'am.
Sai Ram, everyone. My pranam in the lotus feet of Shri Sathya Sai Baba. And I was not here in the beginning because of some work, but I came just 15 minutes after your lecture was being delivered. I'm sorry for that because I wanted to hear it. It's of great use. And so I suppose girls might have listened it properly. हो सकता है थोड़ा आपके सिर के ऊपर से भी गया होगा कुछ, but you know, this type of research It's a wonderful research which you have done, and your students. You have quoted so many students who have done PhD. I thank them all also, being very doing a very hard work to obtain all these results and all. Many things have been explained about the rheological stimulations and all, proteolytic enzymes, how to use them, hydrogelation and all. They are the part of chemistry and they are the part of biotechnology. So I think they might have recorded the lecture. Even if the students, they are not present and not today, they have not interacted, they should be shown those recorded slides so that they may understand. It's a very burning issue because yes, day before yesterday only, the paper was talking about it and the media was also talking about it, how to use such methods to deliver the drugs in a cell. And they are very important, you know, to heal so many cancer and many of the deadliest diseases which are present in the nature and the environment and are coming up due to we are playing with the environment. That's why they are more coming, and we have to be very careful about it and how the drugs are being delivered to you, whether they are reaching your cells or not. It is a very important thing. So what I understood, I told you. Thank you, Madam
Thank you
Neeta
so much,
Dutt,
madam.
and I thank Dr. Radha and your Dr. Priyanka and other students who have worked so hard to do all these experiments. And my, I say, Ashirwad to them for doing that further, and so that they may contribute to the humankind. Thank you very much.
Thank you, madam. Thank you.
So if anybody has questions, you can please ask. Ma'am, may I ask a
Questions from
question?
the student? Yes, please, ma'am, please.
Ma'am, like you just mentioned in your slides that hydrogels are antibacterial and antifungal in nature also.
Yes, yes.
So does that mean that they have a better shelf life as compared to the natural hydrogels which are present in herbal plants like aloe vera and all?
If I understand your question correctly, ma'am, you mentioned that that these are synthesized gels. Okay. So over that, I will not be able to claim too much because in the nature, as I already mentioned while giving my talk, that in nature, there are some molecules which shows antibacterial properties, different sets of molecules showing antifungal. But to the best of my knowledge, I can say there are maybe it is there also maybe one or two where molecules possess both the properties, antibacterial, antifungal, as well as anti-inflammatory activities. That means our molecule can serve three goals together. Till date, very few examples are there in the literature where the designed molecules possesses all these properties. These are all synthesized molecules, synthesized, designed molecules. It is not naturally obtained. Okay.
So do we have you compared them with the natural hydrogels? I mean, it's just a curiosity.
No. I understand. Yeah. No. Madam, you are perfectly right. No, ma'am, we have not compared it with the existing. But the MICs, just let me tell you, the MICs are much even better to the synthetic hydrogels. Yeah. But we are all getting all these ideas from Mother Nature. We are all getting the ideas from Mother Nature, which is helping us, mimicking. This is nothing but a mimicking, peptidomimetics, or mimic means copying. Copying from what? Copying from Mother Nature. Yeah.
Very impressive work, ma'am. Very impressive work. Thank you so much. Any other questions? Ma'am, Kiran ma'am is coming to ask a question.
प्लीज।
नमस्कार
नमस्कार मैम। नमस्कार
मैम, ये मैं पूछना चाह रही थी कि
हाँ,
हम मेडिकल फील्ड के अलावा भी हाइड्रोजेल का कहीं यूज कर सकते हैं, जैसे कॉस्मेटिक या और
कहाँ पे?
मतलब कहाँ पे और यूज कर सकते हैं?
हाँ, कहाँ पे मैडम? जैसे मैंने
हाँ,
बताया
मेडिकल
है,
के अलावा।
हाँ, बायोमेडिकल एप्लीकेशंस के अलावा ये जो हाइड्रोजेल्स, इनका डाइवर्सिफाइड बहुत सारे जगह पे हो सकते हैं, बहुत सारे, बट मैंने प्रेजेंट किया इधर पे बायोमेडिकल एप्लीकेशंस पे। बट यही लिमिटेड नहीं है, इसमें कैंसर थेरेपी, टिश्यू इंजीनियरिंग, बहुत कुछ हो सकता है। फिर दूसरा एस्पेक्ट जो मैंने दिखाया, दैट इज इन एफ्लुएंट मैनेजमेंट, जहां पे अंकिता ने वो HCl एंट्रैपमेंट के लिए किया है, प्लस वेस्ट वाटर मैनेजमेंट, वो भी हमारे ग्रुप का काम है, बट ये 1 घंटे में दैट वाज नॉट सफिशिएंट। कभी दूसरा बार बुलाएंगे तो तब वो कहानी सुना पाऊंगी। बहुत कुछ करते हैं, बहुत कुछ करते हैं मैडम। बट अपार्ट फ्रॉम दैट और भी बहुत सारे ये काम हम अपने ग्रुप हम लोग करते हैं, बट अपार्ट फ्रॉम दिस और भी बहुत सारा एस्पेक्ट्स है जो हाइड्रोजेल्स का एप्लीकेशन हो सकता है। बहुत कुछ है, ये एक मॉडर्न रिसर्च है, इसीलिए आपने देखा कि ये जो पेपर्स है ये कोई पुराना नहीं, ये एकदम रिसेंट पेपर्स है।
यस, थैंक यू।
कुछ बोल रहे हैं मैम?
Yes, ma'am. Our principal ma'am is telling few more uses of hydrogels. She's saying that they have been used to clean the lakes.
Clean the, yeah, wastewater treatment, exactly, wastewater treatment, that is exactly, हाँ, वो हम भी अपने लैब पे कर रहे हैं। दैट इज अपार्ट फ्रॉम दिस और भी बहुत सारा टिश्यू इंजीनियरिंग, रीजेनरेटिव मेडिसिन, कैंसर थेरेपी, डिफरेंट एरियाज में उसकी है। बट अभी वो उस एरिया पे हम लोग काम नहीं कर रहे हैं अभी। मे बी लेटर ऑन मेरे अलग जो दूसरे स्टूडेंट्स है, दे माइट बी इंटरेस्टेड टू एक्सप्लोर। डेफिनेटली मैम, इसका बहुत सारा एप्लीकेशंस है।
That is what she's saying. Practical application बहुत सारी है hydrogens की।
हाँ मैडम, आजकल कोई भी रिसर्च आप करें, अगर उसका प्रैक्टिकल एप्लीकेशन नहीं है तो फिर वो काम करके कोई फायदा नहीं। चाहे आप छोटा से छोटा काम करो, बट आप कुछ बना रहे हो, फिर उसको एक्सप्लोर, मतलब how it can be exploited for various applications. Without application your material is of no use. आपका काम, मतलब गवर्नमेंट पैसे दे रहे हैं आपको, तो कुछ मतलब सोसाइटी के लिए कुछ तो करना है। So we try in this way.
Any more questions? I now take this opportunity to propose vote of thanks on behalf of Chemistry Department. Credit for this interesting lecture goes to our esteemed speaker, Dr. Anita Kunar. Thank you for accepting our invitation to address our students with your enlightening research on hydrogels. I'm grateful to our chairman, Dr. Meena Bindlapure ma'am, who has always showered us with good wishes and blessings. My gratitude to our zealous principal, Dr. Asha Agrawal ma'am, for always guiding us through. Heartfelt thanks to our vice principal, Dr. Jyotsna Galgale ma'am, dear faculty members, and my dear students for your enthusiastic participation. Thanks are also due to our technical team whose support has made this lecture go smoothly. Thank you so much once again. Thank you.
Thank you, Anita madam. Very informative session.
Thank you so much, madam. आप लोगों को अच्छा लगा तो मुझे भी अच्छा लगेगा फिर।
Same here. Thank you so much.
Thank you, madam. और भी बहुत सारा एप्लीकेशंस है हाइड्रोजेल के ऊपर। अगर बाद में कभी मौका मिले तो सुनाऊंगी।
जरूर। हम आपका लैब भी विजिट करना चाहेंगे।
ओके, डेफिनेटली, हाँ, डेफिनेटली मैडम, यू आर always welcome. Oh, ठीक. Okay, madam. So can I leave now?
Yes, you can leave. Thank you.
Okay.
Bye bye.